Be 45 degrees. Okay, that looks beautiful. Let's try one more angle. Let's see. What about
-180?
What'd you say?
-180.
Okay, Allison says -180. Let's try -180. Alright, that looks beautiful. Okay, now let's try goal to goal. So we'll go to like 1-1 because 1-1 is my favorite. I don't know why. So the X is straight ahead, so that would be 1-1. That looks beautiful. How about we try -1? So like, how about -2-1? -2-1. There's -2-1. And we'll try one more. You can put it back to that default position if you want. We'll try 1 -2. X is straight ahead. So okay, that looks beautiful, guys. I think you guys are checked off. Okay, so that's 1-1. So now let's try -2-1. -2-1. Okay, so that's actually your X. Okay, and we'll try one more. How about -1, 2? -1, 2. Oh, I meant to say positive. Sorry, I messed you up. 1 -2. That was my fault. Sorry. 1 -2, because I was like, why is it going that way? 1 -2. All right, that's better. Okay, very good. On a scale of, so this is the robot going to 1-1. That looks great. It's interesting that the angles fix themselves when you do go to goal, though. You know what I mean?
It's calling the same function. It'll do positive 45 degrees and nothing else.
Okay, so let's do 1 -2. 1 -2. That should be towards rain. Okay, that looks good. Now let's do -2-1. -2-1. This will be the last one. And that's going to be back towards the desk. -2-1. That looks great, guys. Okay, you're all done with your demo. -1, 2. Go to goal.
Our procedure is going to be so simple. The only problem is going to be
-1, 2. Very good. We'll do one more since I got the camera out.
Okay.
Can I do -3, -4?
Oops.
-3, -4?
You went to the joke button.
Yeah.
It may hit the wall. Beautiful. Okay, good job, guys. So now the robot's going to go to goal, which is 1-1, which means it should turn and then go forward 1.414 feet. That looks great. What if you were going to go to -2-1? -2-1. Let's start it back at the origin and do -2-1.
Okay. So go to goal. Head down twice for X. And up 1 for Y. Go.
That looks great. Now let's do back to the origin. Last one will be -1, 2. -1, 2. Wait a minute, no. 1 -2. Sorry, 1 -2.
Okay. 1.
So now it should go over to the right.
Go to Y. Going.
All right, great job, guys. 1-1.
Go.
Okay, that looks great. So it should go to about, ooh, no. Go to goal, 1-1. which means the hypotenuse should be about 1.414 feet.
1.
That looks wonderful. Let's try -1, 2, -1, 2, and always start back at the origin to make it easy for us to see.
It can go there from there if you want.
I know it can, but I won't understand if it got there or not.
It'll go to the same spot it would be relative.
I can't rotate my axis like that in my head. Do you not understand what I mean? Chris, I don't know what that's doing. Put it back at the origin.
Okay.
He's just driving around aimlessly now.
We're
-1, 2.
working on getting it to go to any position given its current position.
No, you need to be able to do that in subsequent labs, and you need to keep up with that state.
Shoot.
Like for next week, you're going to need
So we'll
that.
fix the units.
What makes? So I thought you did fix the unit.
Because you want inputs of 1, 2, 3, 4, 5 feet.
That looks good.
-1, 2.
Okay, -2,
So
1.
it was doing-
I'm sorry, 2, -1. I'm sorry, 2, -1. What'd you say? 2,
It
-1.
actually was doing that, that's fine.
Okay.
2, -1. And that's going to be,
It's going to be right here.
yep, right over there. That's right.
-1.
Maybe the math for this lab is too hard. Maybe that's where the confusion comes in. Let's try -3, -4.
Do we have enough space for that?
I don't know. -3, -4 should be 5 feet. Those beeps would drive me crazy, Chris. That works for
We
you?
might change them out. They were there for the first one because you wanted beeps to know which button you pressed.
They may come in handy later. If it hits the wall, you might want to get it. Wow. That is beautiful.